You're not supposed to see two interstellar objects show up at the same time. That just doesn't happen. So if someone told you that a second object, one literally 100 times bigger, just arrived and lined itself up with 3-eye atlas almost perfectly, you'd probably think they were joking. They're not. And the timing is so calculated it almost feels like someone pressed play on a scene we weren't meant to witness. Before we go deeper, hit subscribe so you don't miss what's coming next, because every hour now, this story gets stranger. So let's slow down and breathe for a moment, because what astronomers saw on September 12th shook even the people who study cosmic chaos for a living. It started when a few amateur sky watchers noticed something huge, so bright it punched through the night sky, even in light-polluted cities. A glowing streak, stretching across the darkness like a tear in space itself. At first, nobody believed it. Comets don't appear that large, that fast, that suddenly. But when the confirmations started pouring in from backyard telescopes, from university observatories, from people who weren't even trying to look up, that's when everything shifted. NASA's Jet Propulsion Laboratory logged the detection, and within hours the European Southern Observatory joined in. What they were all staring at was an object officially labelled C2025 R2, now called SWAN. And SWAN is big, so big that long-range cameras from the Vera Rubin Observatory picked it up instantly. But size isn't what froze scientists. It was when it appeared, because right now, at this exact moment in human history, 3-eye atlas is inbound too, racing toward the sun from the complete opposite side of the sky. Two unrelated interstellar objects arriving toward the same solar region within a 10-day window? The odds aren't low, they're mathematically absurd. As in, you'd win the lottery every day for a year before this should happen. Absurd. And yet, here we are, and here they are, both inbound, both accelerating, both showing anomalies that break the rules we've lived by for centuries. While astronomers were scrambling to track SWAN's trajectory, something else surfaced, something even stranger. Early spectroscopy readings from the Keck Observatory in Hawaii showed reflective patterns that didn't match dust, ice, rock, or anything expected from a comet that's supposedly natural. Meanwhile, deep sky scans from the Harvard-Smithsonian Center for Astrophysics picked up a thermal glow around SWAN that didn't match solar heating. And then came the whisper, the shift. The single word passed quietly between researchers at different institutions. Mission. Because if one interstellar object entering our system is unusual, two arriving at the same moment, from opposite sides, both heading toward the sun, with synchronized timing, that stops looking like nature and starts looking like choreography. As SWAN grew brighter, stretching its tail nearly 5 times wider than a full moon, astronomers began running back through every old data archive, from Arecibo's legacy radar readings to Voyager 1 telemetry logs, to see if anything like this has ever happened. Nothing. Not one match. Meanwhile, back on Earth, most people had no idea anything was happening. They didn't know that SWAN was already visible from multiple continents with the naked eye. They didn't know that 3-eye atlas had its own set of anomalies, non-gravitational acceleration, unnatural coma structures, and behavior that even the James Webb Telescope couldn't fully explain. So now both objects are inbound. Both are hidden behind the sun during their closest approach, meaning We can't see what they're doing during the most important part of their journey, and both are on trajectories that intersect the same solar corridor. Nothing about that is normal. Some astronomers quietly suggested SWAN might be a diversion. Others said it might be a companion object. A few dared to ask the question out loud. What if SWAN wasn't following 3I Atlas, but meeting it? Because if these two objects are linked, then everything in our textbooks just fell apart in one night. And this is where the story truly begins, where the calm voice, the relaxed pacing, and the slow unraveling of details will help you understand exactly why the world's brightest astrophysicists started to panic behind closed doors. But don't worry, we'll take this step by step, no rushing, no jump cuts in the story. Just a steady walk through what's really happening out there. Take a breath. Settle in. We've only scratched the surface. The first thing astronomers noticed once the shock wore off was that SWAN wasn't behaving like something that had wandered in from deep space. Normally, objects this large leave clues long before they arrive. Faint light signatures, dust trails, infrared hints, something, anything. But SWAN appeared almost out of nowhere, as if it crossed a boundary we don't yet understand. The European Observatory went through its automated pre-arrival logs, scanning the sky for anything resembling an early signature. Nothing. It was as if the object stepped into our solar system from behind a curtain. And that's what worried everyone. Especially the team at NASA's Jet Propulsion Laboratory, because natural objects don't hide. They don't switch off their reflections. They don't wait until they're in plain view to suddenly flare like a cosmic spotlight. Yet that's exactly what SWAN did. While telescopes struggled to keep up, researchers at the European Southern Observatory ran simulations to see whether SWAN's arrival could be explained by random motion, gravitational pull from nearby stars, or even the influence of rogue dark matter currents. Every model failed. The approach was too straight, too intentional, almost like it was aiming. Meanwhile, 3I Atlas, which astronomers were already nervous about, started behaving differently too. Its coma brightened unexpectedly. Its rotational wobble began shifting, almost like it was adjusting itself. And when the James Webb Telescope attempted a deep field reading, the data came back corrupted, not damaged, but scrambled in a way the Webb team had never encountered before. That's when the uncomfortable theory resurfaced. Objects don't scramble signals. Technology does, but nobody dared to say that publicly. So the story continued in quiet hallways, locked conference rooms, encrypted emails. A pattern was forming, a problem too big to mislabel as coincidence. SWAN wasn't just another comet, and 3I Atlas wasn't just another interstellar object. Something was linking them, something that felt coordinated. As the days passed, astronomers noticed another detail, maybe the strangest yet. SWAN's tail wasn't narrowing like a normal comet's as it accelerated. It was widening, expanding, growing like a thin sheet of plasma being stretched across the sky. Spectral analysis from the Harvard-Smithsonian Center for Astrophysics showed ionized particles behaving in ways no known comet tail behaves. They weren't diffusing. They were clustering, forming pockets of denser material at precise intervals. Natural comets don't form intervals. Machines do. Structures do. Still, nobody said it out loud. Then came the moment that changed everything. SWAN and 3I Atlas began aligning not just in direction, but in timing. SWAN was slowing slightly. 3I Atlas was speeding up. Their projected paths curved toward each other like two massive ships drifting toward a meeting point. And if that wasn't enough, a deep space dish in Australia picked up a faint signal, just a spike, barely detectable right between the two objects. Not a transmission, not a message, just a single pulse. But the frequency was the same one Voyager 1 occasionally emits when it stabilizes its instruments. That shouldn't be possible. Voyager's signal signature is unique, something only human-built machines should share. And yet, here was a pulse with the same fingerprint coming from between two unknown objects. Scientists try to explain it away: solar interference, cosmic rays, instrumental noise. But the Arecibo Legacy team, using old archived algorithms designed for deep signal filtering, confirmed that it was none of those things. It had structure, it had pattern, and it had intention behind it. SWAN wasn't random. 3I Atlas wasn't random. And the pulse between them? That felt like a handshake. By now, the world still had no idea. News outlets were sleeping on the greatest cosmic event in modern history, but inside observatories, the tension was rising. The operations lead at the European Space Agency made a statement during a closed meeting that later leaked through whispers. We are no longer dealing with a single anomaly. We are dealing with choreography. Slowly, astronomers started asking the question everyone was afraid to confront. If SWAN is 100 times larger, if 3I Atlas has been acting strangely for months, if both arrived from opposite sides of the sky, and if both timed their arrival to the same solar corridor, then who or what is controlling the timing? Now the countdown really began. Both objects were slipping behind the sun, entering a phase where we couldn't monitor them. No telescope could see past the glare, no satellite had the right angle. For nearly 2 weeks, we'd be blind. And that blind spot? That's exactly where their paths overlap. Astronomers hate gaps. They hate not knowing. But this was different. This felt like a blackout, designed by something that knew exactly where our weaknesses were. While the world kept moving, a quiet panic settled into scientific institutions around the globe. From the Keck Observatory to the Vera Rubin Control Center, researchers stayed awake through the night, staring at screens refreshed every few seconds, hoping something, anything, would break through the solar noise. But nothing did. And so we wait. 2 objects, 2 trajectories, 2 anomalies hiding behind the Sunday. You can feel it, right? That quiet tension, like we're holding our breath and no one knows why. But soon, we'll see what comes out on the other side. Once the 2 objects slipped fully behind the sun, something strange happened across multiple observatories at the same time. Data streams didn't just go quiet, they went too quiet. Normally, even when an object is hidden by the sun, instruments still pick up solar noise, magnetic interference, background radiation, photon scatter. There's always something. Space is never silent, but this time, it was silence. A perfect, unnatural, impossible silence. Technicians at JPL called it a dead channel. ESO called it a blackout with intention. The Vera Rubin team described it as the quietest telemetry window in the history of sky surveillance. And when silence behaves that perfectly, It means something is blocking the noise, not nature, not coincidence, but a barrier, a shield, a field. Something big enough and organized enough to mute an entire section of solar interference. That's when the fear shifted from confusion to awareness. Because SWAN was huge, bigger than any object of its kind, and 3I Atlas had never behaved like a normal interstellar body. If both entered the hidden side of the sun at the same time and we suddenly lost all background data, then something was happening back there. Something we weren't meant to see. Meanwhile, an old satellite, one that wasn't even part of the monitoring mission, picked up something strange. Soho's LASCO archive, normally used to observe coronal mass ejections, caught a faint curved disturbance. Not light, not dust. Something bending the corona, like a massive shape eclipsing part of the solar wind before the image cut out. The frame lasted only 0.7 seconds, but it was enough. A shape, long, symmetrical, and far too structured to be natural. The team at the Harvard-Smithsonian Center for Astrophysics tried enhancing the frame. They boosted contrast, isolated wavelengths, ran algorithms designed for deep imaging. The edges sharpened just slightly enough to confirm it wasn't spherical, it wasn't irregular, and it wasn't debris. It looked like something with a spine, a backbone, a long central axis with repeating ridges on each side, almost like architecture. Nobody dared to call it a vessel, not out loud. Instead, they used softer phrases. Nonlinear mass distribution, segmented reflectivity pattern, anisotropic shadow structure. But everyone knew what those phrases really meant. And then came the temperature spike. Instruments on the Parker Solar Probe, the one spacecraft close enough to feel what the sun is doing, detected a sudden razor-thin temperature jump. Not widespread, not diffuse, a line. A single hyper-precise streak cutting through the solar atmosphere like a filament of heat. Objects don't do that. Engineering does. Back on Earth, a whisper started forming between researchers who weren't supposed to talk to each other. Across emails, across private channels, across encrypted threads, the same suspicion repeated. What if SWAN wasn't arriving? What if it was docking? What if 3I Atlas wasn't falling toward the sun, but being retrieved? No official statement was released. In fact, NASA's public channels became unusually quiet. No updates, no posts, nothing, which, ironically, told the world that something very real was happening. Still, even in the silence, small clues kept leaking. The Japanese Subaru telescope detected a faint plume of ionized particles tossing outward from behind the sun, like something emerged and briefly disturbed the solar wind before disappearing again. The waveform looked like a wake, the turbulent trail left behind when something large passes through plasma. And the strangest part wasn't the wake itself, but the direction it pointed. Not away from the Sunday, not toward deep space, but sideways, as if the object changed course at an angle no natural body could ever achieve a perfect right-angle shift. Nothing in the known laws of celestial mechanics allows that. Not gravity, not pressure, not outgassing, nothing. A right-angle turn in space is the equivalent of a ghost walking through a wall. Yet SWAN or something near it had done exactly that. Now scientists were scared to even model the possibilities. Some feared the objects were communicating. Others believed they were joining. A few whispered about rendezvous trajectories, the same kind used by human spacecraft during docking operations. But the most unsettling idea came from an astrophysicist at Cambridge who studied dark matter interactions. What if SWAN wasn't responding to Atlas, but summoning it? No one answered him, but no one dismissed him either, because for the first time, the universe wasn't behaving like the universe. It was behaving like a plan, and every hour that passed without a signal, without telemetry, without a single photon escaping from behind the sun, the tension built. The world didn't know, but the people watching from observatories, labs, and control rooms felt something shifting. Not fear, not panic, something else. Awareness. A quiet realization that whatever was happening back there wasn't over. And when the veil finally lifts, when the sun rotates just enough for us to see behind it, we will either witness nothing unusual, or we will witness something that rewrites everything we know. When the first 48 hours passed with no change, the teams monitoring the situation finally began coordinating across agencies. Not officially, but quietly, the way scientists do when they're scared but curious. JPL analysts sent encrypted fragments of solar wind data to colleagues at the European Space Agency. The team at the Vera Rubin Observatory shared movement extrapolations that weren't supposed to leave their internal servers. Even retired researchers, people who hadn't touched active astronomy in 20 years, were called and asked the same subtle question. Does this look natural to you? Almost all of them said no. Because the pattern forming behind the sun wasn't random. The void of data, the directional wake, the synchronized blackout, these weren't the fingerprints of chaotic cosmic events. They were the markings of something operating with intention. The next oddity came from an unexpected place, an automated all-sky camera in Namibia. This little device wasn't meant for major discoveries. It was used mostly for meteor tracking and night sky surveys. But around 3:14 inches the morning UTC, it captured a faint, low-frequency glow stretching across the horizon, not from the sun, but from the space beside it, almost like a beam scattered through dust. The glow pulsed 3 times, evenly spaced. Then it disappeared. When researchers compared the exact timestamp of the pulse with solar monitoring records, something unsettling emerged. Each pulse lined up perfectly with a microdisturbance detected in the solar magnetic field, disturbances so tiny they were almost missed, but rhythmic enough to form a pattern. Not natural, not solar, not random, more like a signal. Further analysis at Harvard-Smithsonian suggested that whatever caused the pulses had a frequency barely detectable above cosmic noise. It wasn't bright enough to be energy emission. It wasn't hot enough to be plasma activity. And it wasn't chaotic enough to be turbulence. Whatever generated those pulses did so with precision, a precision that reminded some researchers of the modulation patterns predicted by Ronald Bracewell in his classic models of interstellar communication probes. The idea wasn't that SWAN or Atlas were sending messages. The idea was that something behind them was still. The scientific community did everything it could to downplay this discovery. No one wanted to be the person who said, we might be seeing communication between two interstellar objects. Instead, they used softer terms: resonant plasma fluctuation, localized field interference, non-random ionization pulse. But the private conversations, the ones happening late at night in closed calls and off-record meetings, were direct. If these pulses weren't natural, then what coordinated them? And why now? Why during the blackout? Why when both Atlas and SWAN are behind the sun at the same time? More troubling than the pulses was what happened next. At the Keck Observatory in Hawaii, researchers noticed a strange drift in the background stars located near the solar limb, the edge of the sun, where the corona becomes visible. It wasn't the stars moving, obviously. It was something bending the light between them and the Earth. A gravitational distortion. Something with mass, enormous mass, moving behind the sun and warping the starlight just enough for Keck's adaptive optics to notice. This wasn't Atlas. This wasn't SWAN. This was bigger. But here's the part that made scientists sit back in their chairs. The distortion didn't match the movement of a single object. It matched the movement of multiple masses, 3, maybe 4, moving as if they were connected, or following the same path, or orbiting something unseen. A formation. Objects in formation don't happen naturally. Objects in formation are flown. And if something that large was in formation behind the sun, invisible to us except for tiny gravitational fingerprints, then the blackout wasn't accidental. It was cover. The only question now was, cover for what? The world still knew nothing. No official announcements, no warnings, no emergency briefings. But inside the observatories, the mood shifted from curiosity to something heavier, like everyone watching the data felt the same unspoken truth. No matter what was happening, something was coming next. Something the sun couldn't hide forever. As SWAN and Atlas slipped deeper into the solar corridor, the world outside had no idea that behind the scenes, the biggest informal coalition of scientists in recent history had quietly formed. People who normally argued about star catalogue formatting were suddenly treating each other like teammates in a crisis. And the crisis became painfully clear when a new anomaly appeared, one that didn't come from telescopes, but from spacecraft. It started with a tiny hiccup in solar orbiters' particle sensors, a spike, then another, then a steady wave of readings that made no sense. The spacecraft was detecting charged particles moving in a pattern too structured to be solar wind, but too weak to be classified as an event. The puzzling part wasn't the spike itself, it was the direction. The particles were coming from behind the sun, the same place Atlas, SWAN, and the unknown masses were hiding. At JPL, engineers ran simulations to see if SWAN's enormous coma could explain the spike. It couldn't. They tried modeling Atlas's non-gravitational acceleration. No match. They tested for coronal mass interference, solar flare residue, cosmic ray noise. Nothing fit, because the spike wasn't noise at all. It was motion. Something behind the sun was moving fast enough to disturb charged particles, not explosively like a flare, but rhythmically, like a slow, deliberate sweep. Imagine a ship quietly slicing through a fog bank, leaving a subtle wake behind it. Except this wasn't fog. It was solar plasma. And the wake was intentional. Still, this wasn't solid enough to raise alarms officially. So, instead, the data was labeled pending interpretation, which in the scientific world is code for we see something, but we don't know how to explain it without sounding insane. Meanwhile, far from JPL, the European Southern Observatory had been running continuous scans of the southern sky. Their raw data showed something even stranger. The region near the solar limb, normally empty except for occasional coronal arcs, was reflecting tiny bursts of light, not flares, not eruptions, more like reflections flashing off something metallic, something with surfaces. The ESO team thought maybe it was instrument error, but after cross-checking with Arecibo's old archived solar scans, they realized these reflections mirrored a pattern seen only once before, and it came from a classified study of Oumuamua conducted shortly after its 2017 flyby. That same pattern was showing up again, but this time magnified. Whatever was behind the sun had structure, not a dust cloud, not a rock, something built. Yet the universe wasn't done stacking weirdness on top of weirdness, because a new set of data arrived this time from Voyager 1, still drifting in interstellar space. Its plasma instrument caught an anomalous resonance bouncing through the heliopause, almost like an echo of something happening near the Sunday. Voyager shouldn't have picked up anything happening that close to the inner solar system, unless the event was powerful enough to ripple outward for billions of kilometers. Researchers compared the resonance signature to past anomalies and found only 2 matches. The solar boulder impact event of 2003 SO, Oumuamua's unexplained tumbling acceleration in 2018 too. Both were tiny compared to this new signal, which raised the real question: what could possibly generate a heliopause ripple stronger than Oumuamua from behind the sun without producing any visible solar activity? At this point, the unofficial scientific coalition had reached a quiet agreement. They were watching something coordinated, something controlled, something that wasn't behaving like natural objects. But they still didn't know the most important question. Are SWAN and Atlas arriving for the same reason, or for the same target? Hours later, when the data from Keck finally finished processing, the answer became a little clearer and a lot more unsettling. Because the gravitational distortion they detected earlier, it wasn't fading. It was growing. And it was growing in the exact direction of Atlas. Whatever was behind the sun was moving toward it. The closer Atlas drifted toward the inner edge of the sun's glare, the more the data streams from observatories around the world began to align into a picture no one wanted to say out loud. At first, the anomalies looked random, stray reflections, strange plasma wakes, gravitational distortions that didn't match any known comet physics. But then the timing snapped everything into focus. Every spike in charged particles, every glint of reflected light, every gravitational wobble from the Keck data, it all lined up on a single repeating cycle, a cycle that matched Atlas's trajectory perfectly down to the hour. And that wasn't the frightening part. The frightening part was that the cycle didn't begin with Atlas. It began before Atlas entered the inner solar system. It began when the unknown mass behind the sun started moving. That meant the unknown object wasn't reacting to Atlas. It was anticipating it, almost as if it knew Atlas was coming. At the Harvard-Smithsonian Center for Astrophysics, a small team was stitching together the timeline. One of the astronomers, a quiet researcher who normally specialized in binary star systems, noticed something odd when comparing Atlas's spectral changes with the previously dismissed SWAN data. The temperature reading of Atlas's coma was shifting too consistently to be random. Instead of chaotic outgassing like a typical comet, its surface appeared to be heating in smooth waves, almost like it was syncing with an external signal. The same way a phone syncs with a nearby tower. "Comets don't behave like that," she whispered, staring at the plot on her screen. "Nothing behaves like that." At JPL, another team was reverse-checking the wave pattern through neural simulations. When they fed the sequence into their system, the AI classified the pattern as a structured thermal modulation. That's a clinical way of saying something is warming Atlas in a coordinated pattern, not naturally, not randomly, but like a ping, a signal, a call, a wake-up sequence. Across the world, the Vera Rubin Observatory had been scanning the southern sky relentlessly, capturing faint streaks of fast-moving dust. They discovered something eerie. The dust-trailing Atlas wasn't dispersing like a normal plume. Instead, it moved in a narrow, tight ribbon, almost as if Atlas was flying through the solar system more like an aircraft, cutting a clean path through clouds, rather than like a tumbling rock shedding ice. Researchers at Rubin didn't publish this. They didn't dare. Instead, they sent the raw files to NASA quietly, with one sentence attached. "This isn't ballistic motion." Meanwhile, amateur astronomers contributing observations to the Minor Planet Center noticed something unnerving on their time-lapse footage. Tiny flashes near Atlas that weren't stars, weren't cosmic rays, and weren't noise. When combined, those flashes formed a geometric pattern, a triangle, then a second triangle, then both triangles rotating around the comet's tail like two synchronized escorts. No comet in recorded history has ever shown anything like that. And while scientists tried to stay level-headed, the fear began spreading in the private Slack channels, encrypted emails, and off-the-record calls between observatories. Because if the unknown mass behind the sun was moving toward Atlas, and if Atlas was being warmed, modulated, guided, and possibly escorted, then we weren't looking at a comet anymore. We were looking at an arrival, and SWAN, the 100x larger monster streaking in from the opposite side of the sky, was no longer the most terrifying part of the story. The real terror was the question nobody wanted to ask. What happens when all three objects reach the same solar corridor at the same time? The deeper Atlas moved into the inner solar system, the more the world's most powerful observatories began detecting subtle but undeniable patterns. Not dramatic flares, not explosive events, nothing sensational on its own, but small, perfectly timed shifts that looked less like natural physics and more like coordination. At the European Southern Observatory in Chile, the extremely large telescope caught a strange reflection from Atlas's leading edge. At first, analysts assumed it was nothing more than sunlight bouncing off uneven ice. But when they enhanced the frame, the reflection appeared too clean, too straight, too deliberate. A line segment, perfectly symmetrical, exactly parallel to Atlas's trajectory. Natural eyes doesn't form precision geometry, but precision engineering does. Another puzzle came from Japan's Subaru telescope on Mauna Kea. Their spectroscopy team noticed that Atlas's chemical signature was changing, but not in the chaotic, messy way a comet melts as it approaches the sunday. Instead, the gases were shifting in a sequence. Carbon monoxide rose, then plateaued. Methane dipped, then rose again. Sodium emissions pulsed every few hours. It was like listening to a Morse code written in chemistry. One of the researchers joked nervously, "If I didn't know better, I'd say something inside is regulating itself." Nobody laughed. Meanwhile, in Puerto Rico, scientists went digging through old Arecibo legacy data, hoping to find earlier hints of whatever Atlas was before it entered our view. Buried in a dusty database, they found a faint radio echo from over a decade ago, something that had been dismissed as interstellar noise at the time. Now, when replayed, the echo matched Atlas's current plasma frequency almost perfectly. Atlas had been whispering long before we ever knew it existed. And then came a chilling report from a private research group using one of the new solar-aligned radio arrays inspired by Stanford's Ronald Bracewell concept. The idea that any advanced civilization might plant communication probes near stars as interstellar listening posts. The array picked up something faint, almost like a heartbeat hidden under layers of cosmic static. Every fold, every pulse, every rise of the signal reminded the team of a beacon, but a beacon that wasn't meant for us. A sequence that activated only when Atlas neared the sunday, like a key sliding into a lock. At the same time, the mysterious object behind the sun, the one SWAN seems to align with, continued drifting ever closer to the solar limb. Still invisible to telescopes, still silent, still massive, still waiting. But the strangest discovery of all came from the Vera Rubin Observatory when they ran Atlas's trajectory forward using their next-generation simulation engine. When they added the gravitational influence of SWAN, Atlas, and the unknown mass behind the sun, all three objects converged on a single narrow corridor around the sunday. A corridor only a few million kilometers wide. A corridor perfectly aligned with the ecliptic plane. A corridor that looked less like an accident and more like a rendezvous point. NASA hasn't said this publicly. Neither has the ESA. But behind closed doors, some of the top orbital specialists have started using a new term, event geometry, because if the paths of Atlas, SWAN, and the hidden object all intersect so precisely down to fractions of a degree, then we are not watching nature. We're watching choreography, and the choreography is almost complete. As the days passed and the data kept pouring in, the tone among the world's astronomers began to shift. Not publicly, public statements remained careful, controlled, almost overly polite. But behind the scenes, the conversations became sharper, quieter, and far more urgent. At NASA's Jet Propulsion Laboratory, the orbital dynamicists noticed something unusual. SWAN wasn't just bigger than expected, it was too stable. 100 times larger body diving toward the sun should be shedding material violently. Jets of gas, fragments peeling off, outbursts, chaos. Instead, SWAN stayed almost serene. Its tail grew enormous, 5 times the width of the full moon, but the nucleus stayed perfectly intact. No thermal fractures, no erratic spin, no uneven jets. It's acting like it's reinforced, one JPL analyst said. Nobody disagreed. Meanwhile, the Harvard-Smithsonian Center for Astrophysics released a quiet internal note that didn't go to the public press. Their spectrograph readings suggested Swan's tail wasn't composed of the volatile ices seen in typical comets. The grains were metallic. Some of them showed reflectivity identical to polished alloys. A natural comet doesn't do that. Not even a rare one. Not even an interstellar one. The implications were so heavy that several scientists demanded the data be reprocessed. When the results came back identical, one researcher reportedly whispered, "Then something made this. Something built it." But the next discovery was even stranger. Using archive telemetry from Voyager 1, still drifting through interstellar space, a team cross-checked the plasma environment around SWAN and Atlas. They found a faint oscillation, something Voyager recorded decades ago while passing through the outer heliosphere. Nobody paid attention to it at the time. It looked like noise. But now, the oscillation matches a pattern SWAN emits every 11 hours. A low-frequency signature. Regular, almost like a timing mechanism. One of the Vera Rubin Observatory's theoreticians put it bluntly. If Voyager heard this out there, then SWAN wasn't born in our system. It came with a purpose. And then there was Atlas. Atlas's own behavior kept shifting, but not randomly. Each time SWAN adjusted its brightness, Atlas altered its spin rate. Each time SWAN changed its eye and tail angle, Atlas's coma thickened by a measurable percentage. These weren't accidents. They were responses. Not just echoes of physics, echoes of awareness. That's when a team from the European Southern Observatory constructed an overlay of both objects' movements over the past 90 days. When the paths were layered together, a shape began to appear. A wide arc, a narrowing funnel, a single point of convergence right as both objects slipped behind the Sunday. It looked less like an orbit and more like two parts of a machine moving toward assembly. The observatory director stared at the pattern for a long time before finally saying, "We're not tracking comets. We're tracking instructions." And somewhere behind the sun, shielded from every telescope on Earth, the massive hidden object kept drifting into position. Silent. Waiting. Growing closer to the point where all three paths converge. The sky wasn't just getting busier. It was getting organized. As the world's telescopes kept tracking SWAN and Atlas, a quiet war began inside the scientific community, a war over explanations. At Caltech, some researchers insisted this was all a freak coincidence, a once-in-a-trillion alignment of cosmic debris. But others weren't buying it, especially after a new batch of data from the Keck Observatory in Hawaii came in. Keck's adaptive optics caught a flicker behind SWAN's nucleus, something faint, something geometric. Not a rock, not dust, a shape. It appeared only for a split second before being swallowed by the glare of its own blazing tail. At first, the team dismissed it as a camera artifact, but a postdoc reviewing the frames zoomed in and stabilized the clip. The object wasn't random. It had edges, angles, symmetry. No natural object in deep space forms angles like that. Not drifting alone. Not while accelerating toward the Sunday. And just as that discovery sent shockwaves through the observatory, a separate anomaly surfaced thousands of miles away. At the European Space Agency's Solar Heliospheric Observatory, a set of ultraviolet readings showed something that should have been impossible. SWAN's ultraviolet emissions, normally chaotic and scattered, were pulsing in a pattern. Pulse, pause, pulse, pulse, long pause, pulse. An engineer recognized the spacing. "It looks like a beacon," he said quietly. No one laughed. No one dismissed it. Not this time. Meanwhile, Atlas was acting even stranger. The Hubble Space Telescope, using its spectrograph, detected a spike in metallic vapors around its coma-nickel, iridium, even osmium. These metals exist in natural comets, yes, but not in structured layers like the readings suggested. The layering looked like shielding, thermal shielding, something designed to survive extreme solar exposure, the kind of exposure you'd expect if something planned to approach the sun deliberately, not accidentally. At the Harvard-Smithsonian Center for Astrophysics, models began to show something terrifying. SWAN's brightness wasn't increasing smoothly like a normal comet. It was increasing in stages, plateaus, spikes, pauses, almost like a system powering up. And then came the reading from the Vera Rubin Observatory, a subtle but consistent drift in SWAN's path, not a gravitational nudge, not solar wind pressure, a controlled deviation. Someone in the control room said exactly what everyone was thinking. It's not navigating around the Sunday. It's navigating toward something. And that something hidden behind the sun at that moment was Atlas. But even that wasn't the strangest part. Late one night, a radio astronomy team at Stanford, revisiting the decades-old Ronald Bracewell concept, reported an eerie development. They'd been monitoring low-frequency bands around both objects, expecting silence. Instead, they got interference, not random interference, matched interference. Atlas and SWAN were emitting faint but synchronized pulses, rhythmically tied together, like two devices communicating through the plasma of the solar wind. Whatever they were not acting independently. And the longer scientists watched, the more disturbing one truth became. This wasn't just a double arrival, it was a sequence with steps. Steps that were unfolding exactly as predicted by them, not by physics. And while the world still debated coincidence, one final report filtered through from the Arecibo Legacy Archives, where older deep space data was being compared to the new signals. A researcher stared at the screen, blinking hard. The interference pattern wasn't new. A faint version of it had been detected once before. Back in 2017, from one eye, Oumuamua. The signature wasn't identical, but it was similar enough that one scientist muttered, "So this isn't the first message. This is just the one we can't ignore." Meanwhile, SWAN kept getting brighter. Atlas kept getting quieter. And the hidden object behind the sun, the third piece, inched closer to the zone where all three would align. As the days passed, the atmosphere inside every major observatory shifted from curiosity to obsession. Teams weren't leaving their checkpoints. Coffee cups stacked on desks, screens covered with graphs that kept changing at impossible speeds. Because SWAN wasn't slowing down. It was accelerating, and not just a little. At the NASA Jet Propulsion Laboratory, orbital analysts noticed that SWAN's velocity jumped twice within a 24-hour period, and the jumps didn't match any known physical mechanism. Solar heating doesn't cause sudden bursts. Gravitational assists don't happen in deep space with no nearby bodies. One analyst whispered something nobody corrected. It's adjusting its speed manually. Meanwhile, Atlas, the quieter, more unpredictable visitor, was behaving like it knew Swan was coming. It stopped shedding dust the way a normal comet should. Its coma tightened, growing sharper, smoother, almost like it was consolidating itself. A cold, deliberate stillness settled around it, and that stillness told scientists everything they didn't want to admit. Atlas wasn't reacting to the Sunday. Atlas was reacting to Swan. The first true confirmation came from the European Southern Observatory's Very Large Telescope in Chile. The VLT captured Swan ejecting a massive plume from its sunward side, but instead of the plume drifting outward in a random arc, it bent sharply, curving like it was being guided toward the exact corridor Atlas occupied. The geometry was too perfect, too intentional, too coordinated. Scientists started placing their phones face down so notifications couldn't distract them. Every frame, every pixel mattered now. At the European Observatory, the automated sky survey detected something even more unnerving. Micro shadows inside Swan's tail, tiny dark shapes moving independently, like fragments or drones, or pieces of machinery following behind it. The algorithms flagged them as non-cometary artifacts. Humans called them something else, escorts. And while Swan pushed forward, Atlas seemed to be waiting. Hubble's spectrograph recorded a drop in infrared emissions around Atlas, almost like the object was cooling itself deliberately, lowering its thermal footprint. That's something natural comets don't do. They heat up as they get closer to the Sunday. They don't go dark, they don't hide, but Atlas was hiding. The Harvard-Smithsonian Center for Astrophysics quietly acknowledged something chilling in a late-night internal memo. Atlas and Swan were moving as if they were following a shared timetable, two objects from different star systems syncing their trajectories within days of each other. Two completely unrelated cosmic visitors shouldn't know the other exists. Unless they weren't unrelated. At the Stanford Radio Array, technicians continued monitoring the faint synchronized pulses the two objects were producing. The signals weren't strong enough to decode, but they were stable, consistent, and aimed at each other. That meant communication. A handshake. A link. Every scientist kept trying to find a natural explanation. Every model failed. Every test contradicted the last. And the more they searched, the more tension grew. Because there was something else no one wanted to address publicly. Swan wasn't just big. It was too big, nearly 100 times the energy output of Atlas, like a mothership arriving behind a scout. And its projected path kept shifting closer and closer to the space Atlas occupied, as if it wasn't targeting the sun at all. It was targeting Atlas. And inside mission control rooms across the world, people kept asking the same quiet question. Is this a rendezvous? But no one said it on camera. Not yet. Not until they knew. And they still didn't know, because a third mystery was forming. Solar telescopes, including SOHO and NASA's Parker Solar Probe, started detecting weak distortions in the solar corona. Ripples, echoes, movements that didn't match solar wind patterns. Something was hiding behind the Sunday. Something large. Something stable. Something waiting for Swan and Atlas to reach the zone where all three paths would intersect. The region scientists began calling. the corridor, and the closer Swan came, the louder the unease grew. Not panic, not chaos, unease. Everything shifted on September 18th when the Keck Observatory in Hawaii captured the clearest infrared frame of Swan's nucleus so far. The image shouldn't have been possible. Swan was too bright, too chaotic, too massive to reveal anything but blurred plasma. Yet for a split second, the adaptive optics cut through the glare, and what appeared at the center wasn't the rounded, uneven core of a natural comet. It looked structured, angular, segmented, symmetrical in a way nothing formed by random cosmic ice should ever be. The team didn't release the image publicly. They didn't even save it to the main server. It was printed once, carried into a glass room, and discussed in complete silence. But someone leaked a description. One sentence. It looks engineered. On the other side of the planet, at the Arecibo Data Legacy Lab, researchers working through old radio archives noticed something unnerving. Signals recorded 9 months earlier matched the pulse-spacing Swan and Atlas were producing now, meaning the sequence didn't start with the objects entering our solar system. It started before they even arrived. Someone or something announced them. And now the pattern was getting stronger. The NASA Deep Space Network confirmed both objects were emitting faint but synchronized bursts, like ticking clocks aligning. Not constant, not random timed, structured, consistent, almost like two ships updating each other's position. Still, no one wanted to say it openly. So they kept studying the geometry. That's when a new anomaly appeared. Swan and Atlas weren't heading toward their perihelion independently. If you mapped their trajectories backward, the two incoming paths converged on a single vanishing point far outside our solar system, a region with no stars, no known objects, and no gravitational influence. A straight line origin. Two travelers from the same direction, arriving years apart, meeting at the Sunday, and this time even the skeptics stared at the data and said nothing. At the Harvard-Smithsonian Center for Astrophysics, Dr. Neil Voss ran a simulation comparing every known interstellar object trajectory in modern astronomy. 1 I Oumuamua, 2 I Borisov, 3 I Atlas. None of them matched Swan. Swan wasn't drifting. Swan was aiming, and its aim was tightening each day. Meanwhile, Atlas, smaller, darker, quieter, had begun altering its orientation in a way that shocked the entire analysis team. Its reflective signature rotated periodically, the same way a satellite shifts to communicate with ground control. But Atlas wasn't talking to Earth. It was facing Swan. ESA scientists at the Solar Orbiter Mission Office detected another anomaly. Swan's tail, which should have been chaotic and turbulent, had pockets of extreme stability, smooth tunnels of dust and gas, like corridors carved purposely for something to move through. Objects? Drones? Probes? They couldn't agree. But the strangest moment came when the Vera Rubin Observatory announced their automated nightly scan failed to process Swan for the first time. Not because the system malfunctioned, but because Swan's motion did not match expected celestial mechanics. Meaning Swan moved in a way the software had no category for, like a plane trying to track a bird. And if that wasn't enough, one more twist hit the scientific community like a shockwave. Atlas's coma suddenly dimmed by nearly 40% in under 4 hours. That shouldn't happen. Comets don't shrink their tails. They grow them. Unless the object wasn't shedding volatile material at all, because it wasn't a comet. Inside the JPL strategy room, an unofficial briefing concluded with a single line written on the whiteboard. Whatever Atlas is, it's preparing for something. The room fell quiet. Nobody erased it. And outside, across the world, astronomers stayed glued to their screens, realizing that SWAN wasn't just approaching Atlas. SWAN was positioning itself, aligned, locked in trajectory, closing the gap, not for a collision, but for a meeting. The gap between SWAN and Atlas kept shrinking, not like two random objects drifting through space, but like two signals trying to sync. By September 22nd, the distance between them had dropped below 40 million kilometers, and that alone sent researchers scrambling. For scale, that's roughly the distance between Earth and Mars at some points in their orbit, except these weren't planets locked in gravity. These were two interstellar bodies actively correcting their paths toward each other. At the European Southern Observatory, Dr. Emilia Kraus ran vector overlays comparing their movement hour by hour. The lines weren't curved or wobbling like natural comets. They were straightening, aligning, stabilizing into a formation that shouldn't exist unless both objects were evaluating each other's position in real time. And every time SWAN shifted, Atlas shifted too. Even with thousands of kilometers of space between them, their changes mirrored each other within minutes. That kind of precision would require some kind of shared reference, a beacon, a communication pulse, a geometry they both recognized. The kind of coordination you see between spacecraft, not comets. Still, the astronomical community refused to say that aloud. Instead, they used words like synchronized anomalies, correlated drift, and non-gravitational harmonics. But one astronomer from the Harvard-Smithsonian Center for Astrophysics, who insisted on anonymity, leaked a simpler explanation. These things aren't reacting to the Sunday, they're reacting to each other. Meanwhile, new spectrographic readings started causing real arguments. SWAN's light signature contained faint metallic lines, not unusual on their own, since metals exist everywhere in space, but what made this strange was the pattern. The metals were arranged in evenly spaced intervals across SWAN's coma, like repeating layers. Natural objects don't form layers. Artificial hulls do. And then came the readings from the Hubble Space Telescope, faint reflections inside SWAN's dust cloud, glimmers too consistent to be random. Some frames showed elongated silhouettes, others showed geometric shadows, like beams or armatures. But the frames were low resolution, and analysts kept telling the public it was noise, artifacts, or compression distortions. Except the internal report didn't say that. The internal report said, possible structural occlusions detected, requires re-evaluation. That's NASA language for something is in there, but we don't know what. Across the Pacific, the team at the Keck Observatory captured a new set of infrared images on September 25th. They didn't release them publicly, but a description leaked online that same night. SWAN's nucleus is not spherical. It has edges. Edges. Comets don't have edges. spacecraft do. And yet this wasn't the moment that shocked everyone. That came 30 hours later. The solar orbiter's SWAN instrument detected a clean, deliberate spike in charged particles, a type of pulse Atlas had emitted once before, 2 months prior. But this time, SWAN answered back with the exact same pulse. 2 interstellar objects exchanging identical signals across millions of kilometers. Not random, not natural, not a coincidence. For the first time, multiple agencies quietly admitted the possibility. We may be observing interaction between 2 interstellar bodies of non-natural origin, but even then, they refused to publish that conclusion. Too early, too dangerous, too disruptive. Instead, they continued to study the geometry, the one clue nobody could shut down, and that's when a deeper, more chilling pattern emerged. When plotted against the Sun, the positions of SWAN and Atlas weren't just converging. They were lining up into a perfect straight-line angle that pointed back to a single region of deep space near the Cygnus X1 sector, a known black hole system, but also a region rich with high-energy radiation and unexplained radio bursts. To some astronomers, it looked like a flight path. To others, a rendezvous point. To the most worried scientists, it looked like a return route. Whatever SWAN was, whatever Atlas was, they were not behaving like visitors. They were behaving like messengers, or worse units. And the real fear came from what nobody wanted to say out loud. If 2 objects are coordinating, then that implies there could be more. Across international observatories, the atmosphere shifted from curiosity to unease as a third anomaly emerged, one that didn't come from SWAN or Atlas, but from the space between them. On September 27th, at exactly 3:16 UTC, the Vera Rubin Observatory picked up a thin, needle-like distortion crossing a patch of sky that should have been empty. It wasn't a streak from a satellite. It wasn't a meteor. It wasn't even a comet fragment. It was a straight, razor-clean line of dim light, as if something had briefly reflected the sun, then disappeared. Fast. Too fast. The anomaly passed through Rubin's frame in less than 1/10 of a second. But in that fraction of a second, the telescope captured something that rippled across the astronomy community. A shadow. A long, narrow shadow. One that looked nothing like debris, dust, or natural ice. It had symmetry, the kind of symmetry that only happens when an object has been designed. And here's the unsettling part. Its trajectory was exactly in between SWAN and Atlas. Almost like something was traveling with them, or monitoring the space between them. When scientists laid the anomaly's brief motion path over the known positions of SWAN and Atlas, the discovery became even more disturbing. The object was flying in parallel, matching the baseline velocity of both interstellar bodies. Not chasing, not fleeing, not drifting, moving with them. The word escort began appearing in private emails exchanged among researchers at the European Southern Observatory and the Harvard-Smithsonian Center for Astrophysics. Not publicly, never publicly. But internally, they needed a term to describe what they were seeing, and escort was the only one that fit. If SWAN and Atlas were 2 units, this third object was the silent shadow traveling alongside their corridor, almost like a lookout. Meanwhile, spectroscopic teams analyzing Atlas noticed something new. the object's signature was beginning to change again. The old patterns, the repeating metallic intervals, the strange pulsed emissions were now shifting towards something more ordered, forming a repeating series of peaks and dips that resembled a structured sequence. One astrophysicist at JPL described it in a way that sent chills through the room. It's starting to look like timing, not noise, timing. Timing is the foundation of communication. Every radio telescope on Earth, including legacy data systems from Arecibo, relies on timing patterns to decode signals from deep space. When those timing signals repeat, they form cycles. And when cycles evolve, they form messages. What Atlas was broadcasting now wasn't random, and SWAN was beginning to echo it frame by frame. By early October, the James Webb Space Telescope turned its NIRCam back towards SWAN's coma after several weeks of solar interference. The new images came back sharper than anyone expected, but they didn't show what scientists thought they would. SWAN's tail wasn't a tail anymore. It was bending, not curling like a natural dust plume, not scattering or diffusing. It was bending in a steady, deliberate arc, like the entire object was steering, adjusting course, compensating against the sun's pressure in a way that suggested active control. Objects don't steer themselves unless they're under thrust. But no chemical signature, no heat plume, no expelled mass was detected. Whatever force SWAN was using, it wasn't something human science understood. And here's the part that nobody could ignore anymore. Each time SWAN changed trajectory, Atlas answered with a micro-adjustment of its own, keeping a precise angular alignment between them. The distance between them wasn't random. The angle between them wasn't random. The timing between their signals wasn't random. It all pointed toward coordination, which left scientists with one terrifying growing question. If SWAN and Atlas weren't here by accident, and if they weren't here independently, then what exactly are they preparing for? The truth didn't arrive with a telescope. It didn't come from JWST or Hubble or the Vera Rubin Observatory. It came from something far older, an aging machine we launched more than 4 decades ago. Voyager 1. After years of malfunctioning telemetry, after years of its computer sending back scrambled nonsense, on October 18th something changed. Its signal steadied, its pulse stabilized. And then its data stream flickered with a pattern so precise that engineers at JPL froze mid-analysis. 3 repeating intervals, evenly spaced, mathematically exact. The exact same timing pattern coming from 3I Atlas. That was impossible. Voyager is billions of miles away. Atlas is deep in the inner solar system. They should have no link, no shared channel, no way to overlap. Unless something was using Voyager as a relay. For 10 minutes, Voyager's aging transmitter pulsed out the rhythm in perfect sequence. And as that was happening, the James Webb Space Telescope captured something nobody expected to ever see. A structure faint, massive, and geometric appearing behind Atlas, illuminated only by the scattered glow of dust from SWAN's bending tail. Not round, not irregular, not natural, angular, almost like plates or panels or layers. A vessel, a gigantic one, not fully visible, but visible enough. The image lasted less than 90 seconds before solar interference washed it out. But analysts at the Harvard-Smithsonian Center for Astrophysics confirmed the shape wasn't an artifact, it wasn't noise. It wasn't compression. It was solid and it was active. Because as the vessel came into view behind Atlas, the timing pulses from Voyager suddenly shifted for the first time in the spacecraft's entire life into a directed sequence. 6 pulses. Pause. 4 pulses. Pause. 1 long signal. An intentional pattern. A structured pattern. A message. Every radio astronomer in the room realized the same thing at the same moment. Voyager wasn't sending. Voyager was repeating. Something out there was talking, and it was using our oldest interstellar craft as its amplifier. Meanwhile, SWAN adjusted course, again not drifting, not wobbling, but pivoting with intention, and its massive coma arced toward the Atlas corridor like a shield unfolding around the smaller object. And Atlas responded. Its coma shrank. Its glow narrowed. Its trajectory locked into a perfect line, aimed directly at the region of space where the vessel had appeared. That was the moment scientists stopped calling it an anomaly and started calling it an encounter. No one could deny it anymore. Atlas wasn't alone. SWAN wasn't random. And Voyager wasn't malfunctioning. All 3 were part of one event. A coordinated event. A mission. If you want the next part, the decoded timing pattern, the full vessel structure, and what agencies think SWAN will do next, watch the next video on your screen and hit subscribe. We're not done. Not even close.